Okay, so lesson 56, solving three-variable systems. So continuing on from yesterday, but we're going to look at some special cases as well. Okay, and again, the steps are the same as yesterday. 1 through 4 are the same. But we have these two additional bullet points. And basically, these are where we have special cases. So just like in two variables, we can have lines that are parallel, right? So there's no solution. Same thing can happen here, right? Those planes could be parallel sort of so that they don't intersect either. So if we ever get a statement that's always false, like 0 equals 5, then there's no solution. Or if we ever get a statement that is always true, like 0 equals 0, so at any point in solving, if we end up with 0 equals 0, or like a true statement, then there are infinitely many solutions. Okay? Okay, so we're going to start with problem 1. So erasing problem 2 for now. We have these three equations, 1, 2, and 3. Okay, so I'm going to look and see which variable to eliminate here. Okay, so I see the x's. It's kind of like a strategy game, okay? So I see in the x, I can already eliminate in the second and third equation, I can eliminate the x pretty easily. And in the first and second equation, I could do that too. Hey, do you guys, do you notice anything about the first equation? What? Yeah, you can divide it by 2. So, why don't we do that? Because then I'll get 3x in that one too, right? So that would make it easier. So, taking that, dividing by 2, I get 3x minus 2y plus z equals, and this negative 15. Okay. No, not really. Because then you'll end up, so you can't do all three at once because if you just eliminate the x's, then you would just end up with one equation in two variables, and that doesn't really get you anywhere. I mean, you could just add them together for fun, but as far as solving the problem, it wouldn't help you a whole lot. Okay? Do you guys notice anything, now that we've reduced the first equation, do you notice anything interesting in these three equations that are kind of bracketed off in purple? They all start with a 3. 3x in particular. Okay, what about the bottom two equations? What do you notice there? Anything else?
Z.
They both have z. So basically the whole left side of the last two equations that we have written are identical, right? So let's add those together because we're going to get a lot of canceling out, right? So if we rewrite these, so this is rewriting equation 3 and then equation 1 after we reduced it, writing that below it. Okay, adding these together, or actually if I subtract, right, that's what's going to eliminate it. So subtracting the whole second equation, x's cancel out. Negative 2y minus 2y, that's just going to cancel out as well. Then I have a positive z minus z. Cancels. So basically on the left-hand side, I just have 0. Okay? Then my equal sign drops down. And I have a 9 minus negative 15. 9 minus a negative 15 is 9 plus 15, right? So 24. What does that tell me based on my rules that I added? Right, there's no solution. So we get to stop. And the problem becomes so much shorter, so we like when there's these special cases, right? Okay, take a second to write this down. Make sure you have it in your notes. Okay, so moving on, here's number 2. I'm looking and I see I have these three equations, right? The bottom equation is already just in terms of two variables, right? I just have y and z. That's nice because that's my first step normally, right, is to get two equations in two variables. So since I already have the third equation in y and z, I'm going to try to get a second equation just in y and z. Okay, and do you guys see that if I take this x I have x equals this, right? So if I take this and plug it in for x here, do you see that my second equation is just in y and z now? If I take that and plug it in for x?
Yeah.
Okay, so I'm going to go ahead and do that. So I'm rewriting this equation 1, 2, and 3. I'm going to rewrite equation 2, but instead of x, I'm going to put negative y plus 3. Okay, so negative y plus 3. Then I'm finishing equation 2, so minus 2y minus 3z equals 9. Okay, so I rewrote equation 2. Now I'm just going to simplify that, okay, combine like terms. I get negative 3y minus 3z. And then this positive 3, I'm going to subtract here so that I have 6 on the other side. Okay, so I'm going to put the numbers together. So this equals 6. Okay, so I have another equation that's just y and z. We'll call that equation 4. And remember, once I have two equations and two variables, I set up a system of those two equations. And my third equation, remember, that's already in y and z, so I'm going to combine equation 3 with my new equation 4. Okay, so rewriting equation 3 below. Okay, and you might notice something about these two equations.
No solution again.
Well, let's see if I go to eliminate any of the variables. Yeah, so if I add the second equation, I'm going to get the y's canceling out, the z's canceling out, and the 6 plus negative 6 cancels out. So I just have 0 equals 0. And which of our special cases happens when 0 equals 0?
Infinite.
Infinitely many, right? Infinitely many solutions.
I just put infinite solution.
Infinitely many solutions. That's technically how you should write it. All right, so let's go on to our third example. Okay, so number 3, we're not going to look at number 4. Okay, so we're going to label these, right? Equation 1, 2, and 3. And then what do we see here? So talk to your partner, figure out what's your strategy here. Okay, so the first step, we always want to eliminate one of the variables, right? It's that tournament idea where we have 3 variables, 3 equations. We want to knock one of the variables out and go down to 2 equations with 2 variables. So somehow we need to get rid of one variable from all of those equations. So which variable looks the best to you? Which one do you think? Talk with your partner, discuss, and I'm going to call on someone to give me their opinion. Okay, Sebastian had his hand up. Do you have a variable that you think we should eliminate? Multiply equation 2 by 5. Guys, focus here, please. You're saying we should multiply equation 2 by 5. Okay, that's something that we can do, but which variable are you hoping to eliminate by doing that?
4.
A? Okay, and then you'll eliminate the A somehow with equation 3 and one of the other equations?
Yes.
Okay, sounds good. So we're going to, we do 2 separate steps, right? So first we're going to choose 2 of the equations to eliminate the A. Then we'll choose another set of 2 of the equations to eliminate the A. So we can multiply by a different thing in each set. So let's look at what that looks like. So I'm going to take equation 1 and equation 2 and try to eliminate the y, right? Or the A. So if I take 5a, do you want to do the equation 2 and equation 3 first? Okay. All right, focus here, guys. We'll do equation 2 and equation 3 first. So if I take equation 3 and I rewrite it, okay, so again, I'm going to eliminate A here. I'm rewriting equation 3. And for equation 2, I want to multiply that. I want to multiply equation 2 by a negative 4 so that the a's will cancel out. So when I multiply by negative 4, I get a times negative 4 is negative 4a. Negative b times negative 4 is plus 4b. Negative 3c times negative 4 is plus 12c, and that's going to equal negative 28. Okay, then combining these together, I can add and I eliminate the a's. Then I get 9b plus 17c equals negative 53. So now I have one equation with just two variables in it. So I need to create another system of three variable equations and eliminate the a. So I'm going to look at equation 1 and equation 2 again. So this is my equation 1, and for equation 2 I'm going to multiply by negative 5 this time so that the a's will cancel out. So multiplying by negative 5, I get negative 5a plus 5b plus 15c equals negative 35. Okay, and adding this second equation to the first, I get my a's canceling out again. Then I get 9b plus 16c equals negative 52. Okay, so now I have two equations in two variables. So they move on to the next step of the kind of tournament idea. So I'm going to solve this system. I'll rewrite the equations here. And I want to subtract now to eliminate the b. Okay, so my b's will cancel each other out. Then I have 17c minus 16c to give me just c. And then negative 53 minus a negative 52 gives me negative 1. So now I have the first variable solved for. I'm going to plug that back into one of the two variable equations. So I'll plug it into the first one. So 9b plus 17 times negative 1 equals negative 53. That becomes 9b minus 17 equals negative 53. Adding 17, I get 9b equals negative 36. Dividing by 9, I get b equals negative 4. So now I have two variables solved for, which means I can plug those two into one of my original three equations. And I'll have a minus, let's say plugging it into equation 2. That gives me a minus negative 4 minus 3 times negative 1 equals 7. Negative times negative 4 is just positive 4. Negative 3 times negative 1 is positive 3. So I have a plus 4 plus 3 equals 7. So a plus 7 equals 7, which means that a equals 0. Okay, so I have each of those solved for, and I can write my final answer as an ordered pair if I want, which would be 0 for A, negative 4 for B, and negative 1 for C. Okay, so this would be like a typical three variable system where I get an ordered pair answer. But again, it could be one of the previous cases where I get no solution or infinitely many solutions. If I get one of those statements like 0 equals 5 or 0 equals some number. But if I get 0 equals 0, then there's infinitely many solutions. So that's all for today's lesson. Thank you.